Good morning, student. Let's start today's class. Okay. In today's class, we are going to study about another encoding techniques, which is called digital to analog encoding. Okay. In previous classes, we have finished the our encoding scheme, which is digital to digital encoding or digital data to digital signal encoding, and this one is digital to analog encoding or the digital data analog signal encoding. And this process, and here in this process we convert the digital data to analog signal. Okay, digital data to analog signal and transmit them in analog channels. Okay, it is the process of changing one of the characteristic of an analog signal based on the information in digital data. That means here what happened, the here we can or we changed one characteristic of analog signal. Okay, or the carrier signal. In modulation we see there is a carrier signal which have high frequency. Okay, that carrier signal amplitude or uh, that carrier signal, one characteristic of that carrier signal is changed in accordance with the digital data which we will want to send. Okay, here you see the process. Sender send the digital data, and inside the modulator the carrier signal or analog signal is varying. The characteristic of analog signal is varying according to the digital data, and it is transmitted through link. And in the receiver side, in the demodulation, the analog signal get reduced or removed from the uh, received signal, and we get our original digital data. Okay, as the sine wave, we use uh, we use a analog signal. Now here in the place of analog signal we use, let's say, sine wave. Okay, naturally sine wave is an analog signal. Okay, and this sine wave have three characteristics. One is amplitude, second one is frequency, and third one is phase. Okay, so according to the encoding process, we vary or we change these between these, or we change these three characteristics in accordance with the digital data given. Digital data, according to the digital data, we can get the encoded signal. Okay, and this conversion or encoding scheme are of three types. Okay, one is amplitude shifting keying, and the second one is frequency shifting keying, and third one is phase shifting keying, which is ASK, FSK, and PSK. Okay, the name refers amplitude shifting keying. Here the amplitude is changed, and in frequency shifting keying, here the frequency is changed, and in the phase shifting keying, here the phase of the carrier is changed, or the phase of the analog signal is changed. Okay, remaining are constant. Okay, from that three characteristic, only one characteristic will be changed, and remaining two characteristics are constant. Okay, in amplitude shift keying. Okay, now let's see, let us discuss about what is amplitude shift keying. Okay, in amplitude shift keying, the amplitude of the carrier signal is vary to create signal element, but both frequency and the phase remain constant. Okay, I also told you that in amplitude shifting keying, the only amplitude characteristic of the carrier signal is changed in accordance with the digital data we given, but the frequency characteristic or the phase characteristic of that analog signal or carrier signal didn't change, remain constant. Okay, now let us see what is binary ASK or BASK. In binary ASK, it used the concept of ASK for digital conversion or a binary conversion. Okay, although we can have several levels of signal elements, each with different amplitude, ASK is normally implemented using only two labels. This this is referred to as binary amplitude shifting keying. In binary amplitude, we use only two levels of voltages. Okay, in binary, due to binary, there are two bits 1 and 0, so we use two voltage level for binary ASK. Since ASK have a unlimited level of due to ASK, the analog signal is related, so analog signal has unlimited level of voltage, unlimited voltage level. But in BPSK we can use only two levels of voltage. Okay, one is, and also the BP uh, and also in for BPSK for BASK, it is also called as on off keying. Okay, on off keying, what is OK. Okay, and the peak amplitude of one signal level is 0 and the other is same as the amplitude of the carrier. Here BSK we use two levels of voltage for coding, for encoding, and that one level is 0 level or 0, and another level is the same as the amplitude of the carrier. That means the amplitude of the carrier is one level and 0 is another level. Okay, here you see this 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 is the digital data given to us, and this is the BP, this is the BP, sorry, BASK. Okay, BSK, and this BSK, due to there is one, the amplitude of the ASK signal is the same as the carrier amplitude. Okay, this is the carrier amplitude, and due to the 0, it is get or encoded as 0, and 1 the same amplitude of the carrier signal, and again 1 the same amplitude of the carrier signal, again 0 the encoded as a 0. Okay, that means when one binary 1 is there, the encoding or the 1 is encoded as the amplitude same as the carrier signal, and the binary 0 is encoded as the 0 level or 0 amplitude of the signal. Okay, next, what is the bandwidth of the ASK? Okay, in the bandwidth of the ASK, remember, 1 plus D into S. Okay, here D is the efficiency, or D is the efficiency of modulator, and this D value varying between 1 and 0. That means, and this value will be given to you in your problem or in your questions. Okay, D may be 1 or maybe 0, which is given to you in the question. Okay, and S is a signal rate. Okay, and S is a signal rate equal to n into 1 by r baud. Okay, I told you the unit of signal rate is baud. Okay, and here S equal to n by 1 by r, n into 1 by r, where n is called the data rate, which is measured in bit per second bps, and the r is the number of data element carried in one signal. That means r is the total number of data element carried in the in one signal. Okay, and n is the data rate or the number of data element transmitted per second. Okay, which is represented by bps, bit per second. Okay, thank you.